Section 3.1 is the derivative in the tangent line problem. We're going to learn about the tangent line problem, the derivative of a function, and differentiability and continuity. So we just finished up with the limits chapter. The limit is the foundation of all calculus. Truly the foundational work of what calculus class is. We are now moving on to derivatives, and derivatives are primarily the vast majority of what Calc 1 is about, your first calculus course in the sequence. So we're going to start off with a problem that we're going to see numerous times throughout the semester. It's probably going to be on almost every single test except for maybe the last test. It's called the tangent line problem. So let's see what we're doing. It says calculus grew out of four major problems that European mathematics were working on during the 17th century. The first one is the tangent line problem, which is in section 2.1 in this section. The second one was velocity and acceleration. Well, we already saw some on velocity and acceleration are in section 3.2 and 3.3. The minimum and maximum problem, which will be in chapter 4, and then the area problems, which is in section 2.1 and 5.2. Okay, so it says each problem involves the notion of a limit, and calculus can be introduced with any of these four types of problems. So all of these problems are connected, and you're going to see how. It says, what does it mean to say that a line is tangent to a curve at a point? When we're talking about the tangent line, what is tangent? It says for a circle, the tangent line at a point P is the line that is perpendicular to the radical line at point P. So it's shown right there. So it says for a general curve, however, this problem is more difficult. For instance, how would you define the tangent line shown in figure 3.2? You might say that a line is tangent to a curve at point P when it touches but does not crosses the curve at point P. This definition would work for the first curve shown in figure 3.2 but not the second. Or you may say that a line is tangent to a curve when the line touches or intersects the curve exactly at that one point. It says this definition would work for the circle but not more general curves as in the third curve in figure 3.2. So we're trying to get an idea of what is the tangent line, because it looks like the tangent line touches just at that point, but again what they're saying is you can't say that because it could technically touch it at more than one point. You want to say that, okay, it looks like it might be, what is it? Okay, so let's go on to the next page and get a formal definition of what the tangent line is.